So one thing I should also mention about this example 3a before we move on to the next one is that we chose to eliminate x by multiplying the first equation by 2 and the second equation by 3 to get 6x here and 6x here. We had another option here. We could have multiplied the first equation by 3 to get a 6y here, and we could multiply the second equation by 2 to get a minus 6y here, and then we could use elimination there, added the equations together to eliminate y. So we had options either way. It's really just a matter of preference or what you find easier. But usually we always do have an option whether we want to eliminate x or y. So just keep that in mind when you solve a problem, because sometimes it is easier to do one over the other. We don't always have to choose x or y. We can choose. Okay, so looking at this next example here, what's different about this one, you'll see that we have fractions involved. So I'm just going to separate these two equations here so I have more room to work with them. If you're not comfortable with fractions, I would suggest doing something to the equation to eliminate the fractions. You can work with fractions if you like, but often it's easier to get rid of them. So what I'm actually going to do here is try and limit the fractions here. My only fraction here is 2, so I'm going to multiply this entire equation by 2. Okay, so if I do that, the 2's cancel here, I'm just left with x. Negative 5y times 2 gives me negative 10y. And 7 times 2 gives me 14. Okay, over here again I have fractions over 2. I multiply this equation by 2 as well. So that will give me 6x plus y equals 23. Okay, these equations are a lot friendlier to work with than the ones we started with. So what we're going to need to do now is try and set these equations up so we can use elimination. Now again, we have a couple options. We can eliminate either x or y. If we want to eliminate x, we have 1x here and 6x over here. So if we wanted to get a 6x in both of them, we could multiply this equation by 6. Okay, and that would give us a 6x here, and that would allow us to use elimination. Again, if we want to use another option, we could try to eliminate y. In that case, we try and multiply this second equation over here. If we multiplied it by 10, we'd have a 10y here, and together with a minus 10y over here, we could add the equations together and eliminate. But working with positive numbers is a little bit easier, so I'm going to multiply this equation by 6 over here to get a 6x. So I'm going to get 6x over here minus 60y. Okay, remember multiplying both sides of the equation, so this would be 14 times 6 over here, which would give me 84. Okay, and I'm just going to number that equation as well, just for reference sake. Okay, so to make things look a little bit easier, I'm just going to move this other equation underneath so things are lined up a little bit nicer. Okay, and then I got to decide if I'm going to add or subtract. Well, I have 6x, well, positive 6x here, positive 6x here. Subtraction will eliminate those two variables. So I'm going to do equation 5 minus equation 4. Okay, so 6x minus 6x give me 0. Here I have negative 60y minus 1y, so I get negative 61y. And over here I have 84 minus 23, so I get 61. Much nicer equation to solve here. So I get y equals negative 1. So from here, just like before, you gotta use another equation to solve for x. You can use one of the original ones here, or you can even use the fact that you've already simplified. Number one, you have x minus 10y equals 14. So if we use that one again, it's a little bit easier if we want to avoid working with fractions again to substitute the y equals negative 1 into there to get our final answer. So make the substitution. You can solve for x there, and by my math that gives me x equals 4. So our POI here should be x equals 4, y equals negative 1. And it is. Okay, so we've gone through a couple different examples of elimination here. You can see that in some cases it would be a little bit easier to use in terms of the algebra than substitution. So let's just take a look at what our main steps for elimination are. So if you want to solve a system using elimination, first thing you're going to want to do is rearrange your equation so you have all your variables and your constant terms lined up. So what that means is if you look at back some of the examples we've done so far, you see we have the x's, the y's, and the constants lined up. Okay, same thing happened down here. We have the x's, the y's, the constants lined up, and if you can go back further, same thing here. X's, y's, constants all lined up everywhere. That's not always going to be the case. In fact, one of the examples we're going to be doing next, you'll see where we have variables all over the place on both sides of the equation. So to make your life a little bit easier, you want to rearrange it so you have your x's, y's, and constants all lined up with each other. Once that's finished, if you have a situation where you have fractions, like working with fractions, much like we did in this last example over here, multiply the equations by a constant to get rid of those fractions. When you have integer coefficients, a little bit nicer to work with, especially when you're trying to figure out, how to get the same coefficient so you can add or subtract the equations. So get rid of those fractions, make your life a little bit easier. Then, if we need to get the coefficients of one of the variables will be the same, so we can add or subtract the equations. So much like we did back here in example 3a, when we don't have the same coefficients right now, we multiplied both these equations by constants, so we could get one of the variables having the same coefficient in front. So that's a key step as well. Then we want to add or subtract the equations to get rid of or eliminate that variable and solve the resulting equation. And then you can, just like in substitution, you sub that result back into one of the other equations to solve for the other one. Okay, so with all those steps in mind, I want you guys to try one final example before we can start into your homework. So I want you to pause the video, try it on your own. When you're finished, push play, and we'll go over the solution. Okay. So first I'll reveal the answer so you can see if you got it correct. So we should have a equals -16, b equals -5. Okay, we'll reveal the steps in a couple seconds. Okay, so what you should wind up with here, first thing you want to do is simplify both sides of the equation. So expand and simplify, collect your like terms, and get your variables to line up. So we have a and b on the left side and your constant on the right side for each equation. So one thing you'll notice here, when you simplify it down here, you get down to 2a minus 8b equals 8. You can simplify your life a little bit further. If you notice that all of these terms, all the coefficients are divisible by 2. If you divide the entire equation by 2, you get down to a minus 4b equals 4. Similarly down here, when you simplify this down, you get 3a minus 9b equals -3. Divide all these terms by 3, you get a minus 3b equals -1. Now this last step down here, this division step, is not necessary. It does make your life a little bit easier. You get to work with smaller numbers, and decreases the chance you'll make a little algebra mistake. So it's a good thing to do if you do notice it. So what we're going to do here now is get these equations underneath each other, so then we can see what we need to do to start the elimination process. Now you will see that we have a and a, just one a for each one. So it's already set for elimination. We just need to subtract the equations now, and we'll be able to eliminate a variable. So we're going to do 3 minus 4. Okay, so the a's get eliminated. We have minus 4b minus -3b, which will give us -1b. And 4 minus -1 gives me 5. So negative b equals 5, or b equals -5. Okay, we can put this into one of our original equations. I'll choose this one right here. So I'll take a minus 4b equals 4. Replace the b with -5. Okay, so you'll see when we work through the algebra here, we wind up with a equals -16. Okay, so that's the final example there for elimination. We're now at the point where we can start our homework, so good luck with that, and come see if you have any questions. Thanks a lot.